Hello friends, we will discuss sequential circuits and systems of the subject digital fundamentals. I will cover this unit. So today I will cover these points, sequential circuits and systems, a 1-bit memory and the circuit properties of bistable latch. In digital systems, there are two types of circuits, combinational circuit and sequential circuit. So what is the main difference between these two circuits? In combinational circuit, the current output depends only on current input. Whereas in the sequential circuit, the current output depends on current input as well as previous output. As is shown in figure, this is the sequential circuit, right? But this part shows the combinational circuit. In combinational circuit, current output depends on current input only. This part is a combinational circuit. Now in the sequential circuit, this output given back to the input, that is known as feedback. You know that. Okay. So this current output we are applying back to the input. For that we require memory. To store this previous output, we will use memory elements and we will give this output back to the input here. So this is known as a sequential circuit. Differences between combinational circuits and sequential circuits. In combinational circuit, as I told you, current output depends only on the current input. So there is no requirement of the feedback and there is no storage element, memory element required. In the sequential circuit, current output depends on current input as well as previous output. We require feedback. We will give the output back to the input. So feedback path is required, as well as to store this feedback previous output, we will use memory element to store the previous output. Now the next point, in the combinational circuit, we are not using clock signals. In the sequential circuit, we are using clock signal. As a clock signal and feedback path, we are not using. So combinational circuits are easy to design. Sequential circuits are difficult to design. Now we'll see the types of the sequential circuits. There are two types, asynchronous sequential circuits and synchronous sequential circuits. Basic main difference between these two circuits are the clock signal. In the asynchronous sequential circuits, there is no need of clock signal. We are not using clock signal. And in the synchronous sequential circuit, we are using clock signals. Now, what is the clock signal? We'll see first, then we'll go ahead. This figure shows the clock signal. It is nothing but the simple periodic cycle. Here you can see this is off time and this is what? On time. In the digital systems, we are using triggering, level triggering, positive level triggering, negative level triggering, as well as age triggering. So what are the difference between these two, level triggering and age triggering? Because in the digital systems, we are using this level triggering as well as age triggering. So first we will see that the difference between these two concepts. So in the clock cycle, you can see here the dark part, blue part shows the level, high level. In some circuits, at this level, at this positive level, the output of the circuit will change, or we can say in another word, the circuit will trigger at this part only. That is known as positive level. Triggering means at positive level, the circuit will change its state. In the negative level triggering, at this low level, you can see here, this is the dark part, at this level only, circuit, output of the circuit will trigger, or we can say output of the circuit will change its state. Okay, at this level. So this is known as negative level triggering. Now what is age triggering? This clock signal will change its state from low level to high level. Means at this age, the output of the circuit will change, or we can say circuit will trigger, circuit will activate at this age only. This is known as positive age triggering. As it is moving, clock signal is moving from low level to high level. That's why it's positive age. And at that age, the circuit will trigger. That's why name is positive age triggering. And negative age triggering. So in the negative age triggering, whenever clock pulse will change its state from positive level to negative level, high to low level. So at this age only, circuit will change its state. Circuit will trigger. That's why the name is negative age triggering. Okay, now we will see what is the bistable element, or we can say 1-bit memory cell. Friends, we are using memory nowadays, in laptop, in the computers, in mobile. Okay, so these memory elements are nothing but the simple, we are using the circuit as shown in figure, or else we are using resistors in that memory. So it contains the bistable element. So now we will see the function of this circuit as shown in figure. We are using 2 inverter. If I will apply the input A, it will give complemented output. So in this circuit, the output of the upper inverter will be given to the lower inverter, and the output of this lower inverter will be given to the input of upper inverter. So if I will give A is equal to 0 to this inverter, then output, that is A dash, is equal to 1. So 1 I am applying here, that is B. So B dash will be 0. Again, I will give here 0, and the cycle will repeat. The output of the circuit is Q, and this is what complement of this output, that is what Q dash. So there are 2 inputs, 2 outputs. A and B are the inputs, Q and Q dash are the outputs. So at a time we will get complemented output here. So these are the different cases I have taken here. Whenever A is equal to 0, in the first inverter, this inverter 1 gives 1. Okay, if I will give A is equal to 0, Q will be 1. And at the same time, inverter 2 means Q dash is equal to, now this Q I am applying to here. So that is equal to B dash. So now we will see, I have taken different combinations, I mean different inputs. A is equal to 0, A is equal to 1. So at the same time, if A is equal to 0, Q and Q dash will be 1 and 0 respectively. And if I will give A is equal to 1, Q and Q dash is equal to 0 and 1 respectively. Now we'll see the circuit properties of this bistable circuit, or we can say latch. We are getting 2 outputs, and these outputs are complemented to each other. The circuit has 2 stable states. Okay, when Q is equal to 1, here when the output Q is equal to 1, this circuit known as set circuit, I mean set mode. Okay, so whenever Q is equal to 1, the circuit is in state set state. Whenever Q is equal to 0, the circuit will be in reset mode, reset state. The circuit can store 1 bit of digital information at a time. And so it is called 1 bit memory cell. Because at the output we are getting Q and Q dash. So Q will be the 1 bit memory. The 1 bit information stored in the circuit is logged or latched in the circuit. The circuit is also known as latch. Okay, at a time it will store or latch 1 bit data. That's why the name is latch. Okay, friends. Then now types of this flip-flops we will see in the next lecture. Thank you.